Now, let's try to summarize what we have analyzed in the previous video. So if we happens to have a velocity time graph like this, a horizontal line, we know that it has a zero gradient because it's flat. Because it's flat, you know that zero gradient means zero value of acceleration. Thus, you should see nothing or you should see zero for your acceleration over here. Okay, then the next thing, we also know that if our velocity time graph looks like this, we know that this is a positive gradient. Positive gradient of VT graph tells us that it's a positive value for AX. And since the gradient here is constant, you should expect that the line is a horizontal line. Okay, because the value of acceleration doesn't change with time because it's a constant value. Constant value because it's a constant gradient over here. Okay, then of course we also know that if our velocity time graph looks like this, a negative gradient, you should expect a negative value of AX. So negative value of AX, you should expect your acceleration time graph will be plotted below the time axis. And because this gradient is constant, the gradient constant means the value for AX is constant. So you should expect a horizontal line to show that it is a constant acceleration. Okay, now there's one thing I'd like to relate this whole summary with. Previously, we discussed about the idea of speed up, slow down, accelerating, decelerating, and positive and negative acceleration, right? Let's try to relate these few terms together here as well. Okay, if you notice here, the velocity is positive, and at the same time, the acceleration is positive. If the velocity is positive, it means it is moving in the positive x direction or positive y. In this case, positive x. Positive vx means you're moving in the positive vx direction. Positive ax means by your acceleration is in the positive direction. So if your vx and your ax are pointing in the same direction, what does it mean? It means the object will be speeding up. Okay, same sign. For v and a, you get a speed up. Therefore, if you look at the graph of velocity here, you notice that the value here is increasing. You go for 2, 3, 4, 5, 6, you get larger and larger value. Okay, we don't look at the sign, just look at the value. Okay, next, let's look at this graph. This graph here is a positive Vx because it's above the time axis. The value of velocity that you get is positive value. That means your velocity is pointing in the positive x direction, or I can say it is moving in the positive x direction. For your acceleration, you get a negative value here because it's below the time axis. So if your acceleration is negative, it means your acceleration is pointing in the negative x direction. Your velocity in the positive x, your acceleration in the negative x. So these two are opposite direction. So if you see opposite direction for Vx and Ax, you should expect it to slow down. And that's what happened. Because if you see here, as time goes by, your velocity actually gets smaller. It goes from 5, 4, 3, 2, 1. The value of your velocity gets slower. It gets smaller, or you can think it's slowing down or decrease in speed. Okay, so that's how you see. Same sign, speed up, opposite sign, slow down. Even if today if we change everything to be below the time axis, you still remain a positive gradient, so you remain a positive value. You remain a negative gradient, so you remain a negative value. Now let's try to reinvestigate whether it's speed up or slow down. Look at the velocity time graph. It's below the time axis. That means this velocity that you get here are all negative value. You get -1, -2, -3, -4, -5. These are negative value, so you get negative Vx. It means you are moving in the negative x direction, or you say your velocity is pointing in the negative x direction. Okay, your acceleration here is above the time axis, so that means your acceleration is pointing in the positive x direction. Velocity in the negative x direction, acceleration in the positive x direction. So these are opposite direction. If you see opposite direction, what should you expect? Slow down. Let's check whether it's slow down or not. As time goes by, my speed is decreasing. My speed is decreasing because even though it's negative, let's ignore the negative and look at the absolute value. It goes from 5, 4, 3, 2, 1. Okay, you get smaller and smaller absolute value, so it means you are slowing down. Okay, let's look at this part over here. we know that this velocity time graph, the velocity is being plotted below the time axis. So these are all negative velocity pointing in the negative direction or moving in the negative direction. Okay, your acceleration here is also below the time axis. That means you are also having negative acceleration. So your velocity is pointing in the negative x direction. Your acceleration is also pointing in the negative x direction. So they are in the same direction. So if you have same sign, your velocity and your acceleration are pointing in the same direction, you should expect same sign, speed up. And let's check whether it's true or not. As time goes by, our value gets larger and larger. Okay, you look at the absolute value. Just look at the absolute value. Our absolute value is getting larger and larger. Go from 1, 2, 3, 4, 5. Ignore the negative, just look at the absolute value. It gets larger and larger. So this is how we check whether an object speed up or slow down. Okay, if an object is a positive acceleration, you don't know whether it's speed up or slow down. You need to see whether the velocity is also positive or not. If it's also positive, then it's speed up. If it's opposite sign, negative, then it slows down. Okay, so that's how you determine whether an object speed up and slow down. And this is a summary of how you relate from the gradient of a velocity time graph to the value that you should obtain for the acceleration.